So we're shifting gears a little bit now. We've been talking about some geological phenomena like earthquakes and volcanoes. And now we're going to turn our attention to Earth materials. What's the Earth made of? How do we describe these materials? And what use are they to society? One way to approach this subject is to think about the objects that are in the space around you. For example, here's a picture of a random Midwestern American living room. Some of the materials in this photograph are from biological sources to start with. For example, the wood tables. But some, such as the wallboard that makes up the walls of this room, are composed of geological materials. Specifically, the wallboards in this room are composed of gypsum board, which is composed of the mineral gypsum, which is a kind of mineral that forms by precipitation out of salty water. There are also many other objects in this room that have geological origins. For example, the metal in the fireplace grate. Metal comes from minerals that contain metal as part of their composition and is then extracted through the process of mining and then refined to form usable metal. So my point is that a lot of what we use in everyday life come from geological materials. So the purpose of our discussion today is to understand ultimately where these geological materials come from and how they're organized and how they're composed. We're going to begin our discussion by making some basic distinctions among different types of Earth materials. We're going to start by looking at the difference between organic and inorganic materials. Then we'll turn our attention to metal versus non-metal, then glass versus mineral, and finally mineral versus rock. We'll build on this concept in succeeding discussions as we learn how each of these kinds of materials behaves and how they form. So let's start with a fundamental distinction between organic and inorganic materials. Organic materials are materials that are based on carbon-based molecules that have a structure similar to the kinds of structures that you might find in living organisms. Originally, people made the distinction because they extracted those chemicals from living organisms. But now it's possible to create organic chemicals synthetically, but yet they have the same basic structure, carbon-based molecules. Sugar, for example, is an organic chemical. In contrast, inorganic chemicals are different. For example, salt, what you see coming out of a salt shaker on the right, is composed of sodium chloride. It's not an organic chemical. It's not based on carbon. It has a different kind of structure, different elements. Now, that said, it's a little bit difficult to make a 100% distinction based on just the presence or absence of the element carbon, because pure carbon, such as you might find in diamond, well, a mineral like diamond is considered inorganic. Similarly, calcium carbonate, another mineral that we'll see, the mineral calcite, is also considered to be inorganic. But for the sake of our discussion, realize that there are some carbon-based elements that are organic. In fact, most carbon-based elements are organic, whereas a few, like diamond, graphite, and calcite, are considered to be inorganic. And then everything else that's not a carbon-based element is considered to be inorganic. The second distinction is between metals and nonmetals. Now, if you think about it, you're all familiar with metal. There are metal coins, metal keys, metal wires, metal pipes. These are things that we use every day. The surface of a car, the skin of a car is made of metal. What is it that's unique about metal? Well, for one thing, it's shiny. For another thing, I'm not quite strong enough to bend this metal key, but typically you can bend metals, you can stretch metals, you can pound them with a hammer and flatten them. They have specific characteristics that reflect their internal structure that make them metallic. The other thing about metals is that they are able to conduct electricity, and that has to do with the nature of the chemical bonds that occur within the metal. Contrast a metal with a piece of nonmetal. This happens to be a piece of coral, but it's not shiny, it doesn't conduct electricity, it has many characteristics that are very different from metal. So we've seen the distinction between organic chemicals and inorganic chemicals. Now we see the distinction between metals and nonmetals. Another distinction is between glass like in glasses, glass in windows, glass in lights, and so forth, and minerals, such as the individual grains that make up this piece of rock. Well, we'll see that there are very distinctive differences in the internal characteristics, the way the atoms are arranged within a glass versus within a mineral. Finally, there's the distinction between a mineral and a rock. A mineral, as we'll see, is a single coherent piece of a single unique composition. Often it will have specific characteristics that are geometric, color-wise, and so forth, whereas a rock is an aggregate of many mineral grains put together in some way. So geologists make a distinction between mineral specimens and rocks. So in any case, notice that all these materials, like everything that's in the universe around us, is composed of atoms. And as you recall from high school science or an earlier science course, atoms internally are composed of protons, neutrons, and electrons, with the exception of hydrogen, which has only one proton. Remember, a proton has a positive charge, an electron has a negative charge, and a neutron has a neutral charge. Now, we distinguish between different elements, as you probably recall, by their atomic number. So for purposes of our discussion right now, remember there are some small atoms, ones that have small atomic numbers like hydrogen and helium, and atoms that have large atomic numbers like iron or carbon, or even really large atomic numbers such as uranium. That's going to become important because now we're going to turn our attention to the question of where do all these atoms come from? Because remember, we want to start our understanding by understanding where geologic materials come from. And to do that, we have to backstep a little bit to understand where the materials that make up our universe come from in the first place.